Here's our original. Here's our transformed equation. We've got a negative in the parentheses and this 1/2 in the parentheses. Okay, so that's two transformations that are different from our original. Okay, if you remember or you can figure it out based on what we already know, tell me. Otherwise, look on your little chart that we just glued in there. What is a negative just in front of the x going to do? What is a negative going to do anyway? Reflect, right? And it's in the y-axis. If it was in the x-axis, it would be right here. Okay, if it's just in front of the x in the parentheses, that's going to reflect in the y. Right, and the 1/2 in front of the x is what? Right, horizontal stretch by 2. Thank you, exactly. Okay, h stretch by 2. Remember, horizontal is just the weird one. You always have to flip the fraction. Okay, if it was vertical, it'd just be a number right out here. Okay, it's the very first thing you'd see. So this is going to flip. And again, I would use these little examples if you have trouble with this stuff, okay? Because the example, it looks really similar, okay? They've got a fraction here. This one's by 3 because it's 1/3, but this one is really similar to this, okay? It looks almost the same. All right, and let's do this in our calculator to see what it looks like, okay? Because we haven't looked at logs yet. Okay, so the log button, it's by the 7. Okay, so in the first one, I'm just going to do log x. It gives you the parentheses on its own. Okay, so f of x, I'm going to do log x. G of x, I'm going to do log, again, it's right beside the 7, negative 1/2 x. Right, then we can graph it. Okay, a log is an inverse of an exponential. Okay, so it looks similar to the exponential, but it flipped over this line right here, the diagonal line. Here's my original log right there. And we say it reflected across the y-axis. Again, this is not the best graph. Sometimes they're not the best. That's why we looked up what to do first before we looked at the graph. Flipped across the y-axis. And since it was horizontal stretch, okay, that means it's stretching this way horizontally. It's getting skinnier and skinnier. That's why you can tell it's a little bit flatter on this side than it is on this side. All right, so I'm going to go ahead and just do my little sketch graph here. There's my x, there's my y. My original one looks like this. And the second one's going to show it reflecting across the y-axis, but also it gets flatter. Okay? You can barely see it. All right, so try to make it clear. And number 6 is going to be the last one that we graph. Okay, the rest we're not going to graph. We're just going to write the equation. Okay, this is natural log. Okay, it's a button on your calculator. You don't have to worry about it. It's just like log. All right, it's going to be very similar to log. ln x, and then this one is 2 ln x plus 4. Okay, so we've got two transformations to identify in our g of x. All right, we got the 2 out front and then the plus 4 in the parentheses. All right, those are the two things we got to point out what they're doing. Okay, what's a 2 out front going to do? Vertical stretch, right? It stays the same number, right? You don't have to flip it or anything, and it's vertical if it's out front. V stretch by 2. Right. What about a plus 4? Is this up 4? Right. Now it's in the parentheses. If it was up 4, it would be out here. All right, left 4. All right, left 4. So we're going to do a little sketch of this one as well. Let's go ahead and check it out in our calculator. Okay, so we can see what's happening and see how much we can see. To use the LN, it's the button we've been using for E. Okay, LN, just the X. And then 2 LN X plus 4. All right, and we said it should move left 4 and vertical stretch. Okay, so there you go. I'm going to draw my first one. Starts here. All right, and this one went left 4 and it goes up higher. All right, because we know it went left 4, but vertical stretch makes it stretch this way. Okay, so it's getting farther away from the x-axis, so that's why it looks bigger and like lumpier. Okay, it goes down more because it's a vertical stretch. All right, they're not exactly the same. It's a different type of log, but yes, you'll treat it the same as a log. Yeah, it's a natural log, and you don't really need to know the difference today. We'll learn more about it in the future, but yeah, it's the same. It's another kind of log. Okay, and on the last 2, okay, we have 2 more, 7 and 8. They're going to give us the words, the transformations. We have to write the equation, okay? So it's going to be the opposite of this. Here, they gave us the equation. We said what was happening. Okay, now they're going to give us this, what's in red. We got to write the equation. Okay, so number 7. Let G be a reflection in the x-axis followed by a translation for units right